Hello everyone. In this video we are going to talk about classes and objects and then derived classes and inheritance. So if you remember from my C++ videos and in general, you know that a class is like a blueprint for object and is basically a type of data that you can create by yourself to have its own variables and its own functions, and it's self-contained, so it makes the program basically a lot easier to maintain. It makes the program what we call object-oriented programming, and this is a favorite topic these days. So in C++, if you remember, your variables and your functions in general can be private, public, or protected. In Python, there is no private or protected by default, and everything is public. But the idea of the variables, constructor, destructor, custom methods, and so on, still there. So if you want to create a class, you start with the keyword class, and then you give it a name, anything you want. And then the parent class is always going to be basically creating objects. Okay, so class box object, this is a parent class. This is a class that you can get other classes, subclasses from it. It might have a constructor, and a constructor, which is a method that starts off and creates an object from a class, is starting with the def, because it's a function really. So you start with def, and then the word init, which is for initialization, is going to be followed by def, but on both sides of this init there are two underscores. Okay, so here as you can see, right, you see here there are two underscores. You need on the left and the right side of it. You have the word self, which basically refers to the class itself or to the object. And then you are giving it all of the numbers that it needs for its variable. So this class that I created called box, it has three variables: length, width, and height. And I get those numbers from here, and then I pass them to what? I pass them to these basically three variables. If you want, you can call them something else, x, y, z, and here say x, y, z, assign them to self length, self width, and self height. This height and this self height are two different things. This height is a number that is a variable of the class box, basically. So this is your constructor. Then you can have a method that will get the data out of the object for you. So we can call it get data, or whatever you want to call it, of self, and it returns for you self.length, .width, and .height, and it returns them all as a single vector. So if you have an object that you read from, let's say, this class from somewhere else, and you want to get the data, you can call this method for it. Here I have a custom function that returns the volume of the box, which is of course the product of self length times self width times self height. And you can have a destructor, which frees up memory for you. And again, on both sides of the word del, which is for delete, and with two of these underscores, and self, basically, if you want, you can show something on the monitor, or if you don't, you can just go ahead and comment this part out. So you don't need to show anything when you apply the destructor. Okay, as long as in your code you say del and then you provide the name of the object from a class, that object is going to be cleaned up from the memory, and the memory is going to be what? Is going to be cleaned. So you really do not need to what? You do not need to print something after that variable or that class is eliminated from the memory. But here, just for the sake of demonstration, to show that this destructor has been applied really, I'm showing a message on the screen that's saying, hey, the structure applied or was applied, or the memory is cleaned out of this variable or something like that. So this is my class. That's the definition of the class. And now here I have a test code. I create an object called box1, which is from class box, and I give it three numbers, 5, 4, and 3, which is going to be passed to this constructor, and those numbers are going to sit here, here, and here, and then will be set to the length, width, and height. So this is a box of length 5, width 4, and height 3 units. And then I can get the data from that box, which are of course going to be these numbers, and then I can call that function to calculate what? Volume of the box, which should be 60, right? And here you see I'm using the dot operator to access those functions, and then I don't really need to pass anything to these two functions, because you see all they get is self, no extra information. And so these two are going to give me the numbers, and then I can get rid of that object box 1. So let me go ahead and run this for you. See, so the first one is the volume, which is 60. The next one is give me the data. It does, and then I delete that, and then this print here is going to show up on the screen. So this is how you create a parent class, and this is how you can provide the numbers to the variables and call the functions, and then of course delete that variable out of memory to clean up the memory. Okay, so you see everything is clean cut, everything is in good shape, no worries. Now here, let's raise the bar and go to the next level. So sometimes you need to what? You need to derive from a parent class what we call a derived or a child class. Why? I talked about it in my C++ videos, but the goal of child classes is to inherit or take away the same variables and the same methods of the parent class, but at the same time giving this child class the possibility to create its own variables or create its own new functions. So a child can have everything the parent has plus some extra thing. And this way, instead of defining a new class from beginning, from scratch, by just saying this class empty box is from the parent box, I do not need to what? I do not need to get to write for it this method, or any of these variables. None of these I have to repeat. I have to copy and paste into the definition of this empty box because the parent of it is class box. So this makes your code shorter. It makes the maintenance of the code a lot easier, and you can always add whatever you want to it. So look what I'm doing. This is my parent class. As I said, it creates objects. Now here, this empty class is from parent class box, right? That's how I know I have a child class. And now look, the constructor for this is not only it has length, width, and height, it also has now three new variables: cut length, cut width, and cut depth. So I assume that on the top surface, you go ahead and create basically a sketch with length, cut length, and width, cut width, and then cut it down for a dimension of cut depth, right? So it's a box, like an empty box, like a basket. And for this guy, I have three new variables, and I'm gonna get these numbers and I'm gonna assign them to these three new variables. So do I need to repeat this part too? No. You see this part that I assign height, width, and length, I don't need to repeat that in this constructor. Why? Because this part is automatically inherited from the parent. Okay, you see, that's the advantage. But you need to do something to set those values. So whenever in my test code, I call this empty box with 6 variables, these 3 are going to be taken by my constructor, and then what? They are going to be assigned to these 3 variables: cut length, cut width, and cut depth. So it's going to take over these three variables and assign them. So you might say, how does it assign the first three numbers to the length, width, and the height of the box? For that, as I said, you do not need to repeat these three lines of code, but you do this line of code, which is invoking the what? The constructor of the parent class to do the job for you. So what do? You say, hey, box initializer, box constructor, I'm going to get these three numbers that the user gave me, and I'm going to give them to you. You go ahead and assign them to those three variables. You see? So this part here is calling this function to do that setup. So that function is going to perform these three lines of code basically. You see, you're invoking this guy of the parent to do that job for you. You don't do it yourself. And then, can I change the definitions of the functions that I inherited from the parent? So when in my parent I said get data, it only gave me 3 numbers. But now when I want to get data, guess what? I need to return 6 numbers. So I add those 3 extra numbers to that vector, right? When I want to calculate volume, in the past it was a solid box, so I just multiplied width, height, and depth together. Here I have to subtract subtract what? The volume of the empty part from the volume of the solid part and give you the total volume. And guess what? I can create a new method that was not available for my parent, and that is the external surface, extsurf. And this is the external surface of this box. So you see, I can create my own thing. I can change the definition of the methods for my parent. I can add new variables. If there are new variables, my instructor will assign it. If there are old variables, I would call my parent's instructor to assign them. Okay, this is the whole idea of what a derived class or a child class. So now, and this idea that this guy takes over those numbers and functions and something, we call it what? We call it the inheritance. So now my test code, I pass these numbers to a new object called empty box1, which is of class empty box. And then I ask it to give me the volume, I ask it to give me the external surface, and I ask it to give me the data of that, right? So let's go ahead and run this. And let me add this constructor here also for this part. There we go. So save and run. You see now the volume is 52. Why? Because the volume of solid is 60, and then the cut part is 2 by 2 by 2. So that's 8. 8 minus 60 minus 8 is 52. The surface area is 110, and the data are, of course, the same as this guy. Yes, so this is how you create a class, a subclass, and do the inheritance, which is done automatically. You don't need to do anything for inheritance, but you can change the definitions. So hopefully this video is useful to you, and I am going to see you in my next lecture. Thank you.